Children, just put on your camera. Saad and Umair, put on your cameras quickly. And then, children, I have to start ahead. One second, children. My pen is not working. Just give me a second. All completed. Real numbers. And then we were doing polynomials revision, right? In the last class. So we will just continue ahead with polynomials only. And before that, you all can tell me if you've got any doubts regarding any of the previous classes, any of the questions that we've discussed, anything that we were not able to understand.
No, ma'am.
Everything was clear. So I
Yes, ma'am.
basically talked about in the last class, what all things did I talk about? I talked about what are polynomials, what are the degrees of the polynomials and everything, right? Then we also discussed the degree of the polynomial is basically the highest power on the variable. That's called the degree. So, so according to the degree, how many types of polynomials do I have? According to degree, how many types of polynomials can I have, children?
Many, ma'am.
Many? Who is this? Umer? What is
Yeah, you can
many?
have a linear or
Or you name them, right? You tell me the degree and name them accordingly.
yeah. If you have one as the exponent, it's linear. If you have two as
If
the
my degree
exponent,
is
it's
1,
quadratic.
so that's called linear. If my degree is 2, that's called quadratic. If my degree is
And if it's
3, that's cubic. Now
cubic,
tell me, what is the graph of a linear polynomial look like?
it's a single line.
It's a straight line, basically like this. Okay, it's a straight line. Now, so how many zeros exist for a linear polynomial?
There is only one zero.
Yeah,
Only one zero. One or no
only one
zeros.
zero. Only one. Okay. Then does the graph of a quadratic polynomial look like?
It's a parabola.
It's a parabola, right? And how many zeros exist for a quadratic?
Two.
Two.
Two. Yes. It can be either in anywhere on the any of the axis, and the number of zeros is 2. What about cubic? The number of zeros is 3, and it can be basically like this. Okay. Now, next, children, we come across various questions. So we came to relationship between zeros. So what is the relationship between zeros? If I have two zeros like alpha and beta, so what is the sum of the zeros? Tell me what is the sum of the zeros?
Sum of
Minus
the
b by
zeros is
a.
minus b by a.
Minus b by a. If I have to find sum of the zeros, that's minus b by n. And what about the product of the zeros?
C by a.
C by a. Exactly. Children, please just give me a minute. I'll rejoin the meeting. My pen is not working. Just give me a minute. Yes, children, am I audible?
Yes, ma'am.
Yeah. So children, please tell me. First of all, put on your camera, children, all of you. All right. So I was telling you about sum of the zeros and the product of the zeros. So we studied in the last class, children, that sum of the zeros is basically minus b by a. B is what? B is the coefficient of the second term. Okay, x. And what is a? A is the coefficient of the first term. And what about c? C is the constant term. Right? The general formula for writing a quadratic equation, who will tell me? What is the general formula?
A square plus b is a x square plus bx plus c.
Right? Ax squared plus bx plus c it is. So, so k is the coefficient. Constant. Okay. Now, children, with respect to this only, if I have alpha and beta, two zeros of the polynomial, and if I add them, so my formula becomes minus b by a. And if I have to multiply them, so that becomes c by a. Okay. So, children, now the question is, let's suppose find a quadratic polynomial. The sum and the product of the zeros are minus 3 and 2 respectively. So earlier what the question was that basically they're giving you the polynomial, they're giving you the relationship and they're telling you to verify it. Now they've not given you the polynomial, but they've given you the sum and the product of the zeros. So we know that for a quadratic polynomial, there are two zeros, alpha and beta. What it is given to us is the sum is minus 3. That means alpha plus beta is minus 3. And what is the formula for alpha plus beta? Minus b by a. Alpha into beta is 2. What is the formula for alpha into beta? C by a. So this part is given to you already, right? This minus b by a and c by a, we've known it already. Now what happens is you basically have to deduce a quadratic polynomial out of this, right? So how can you do that is, see children, I know the general formula for writing a quadratic polynomial is ax square plus bx plus c. So from these things, what I have is the value of minus b by a is minus 3. There is no denominator, so I can put the denominator as 1. Minus sign cancels with a minus sign. So I have b by a is equals to 3 plus 1. That means, children, b value is 3 and a value is 1. Okay, now I don't have the c value, but again you have from the second part, I have c by a is 2 by 1. So c is 2 and a is 1. Okay, so now children, you can just simply substitute the value of a, b and c in these equations. So a value is 1. See, you can check from both the ways I'm getting a as 1 only. So 1x square plus what is the b value? 3. 3x plus what is the value for c? 2. Okay, so your answer becomes x square plus 3x plus 2. Tell me, did you understand this? It's very easy. You just have
Yes,
to
ma'am.
focus
Yes,
very clearly. What we are doing here is the relationship between the here the relationship is not asked to you, but what they're asking you is basically the sum and product is given to you. You have to deduce a formula out of that. So you just have to write this step. You'll get the value of a and b. Simply put it in the general formula. Okay. Quickly complete this and tell me. Then do it. Then we'll go to cubic polynomials. Okay.
Ma'am,
Done?
no, ma'am, 1 second.
Okay.
Ready.
Okay, children, did you also understand it?
Yeah, ma'am.
Understood as well? Saad, what about you? Saad, your camera is off.
Yes, ma'am.
Now, children, let's consider what they're telling you. See, this all of this part is very important. Now they're telling you about a cubic polynomial. So what is the general formula for a cubic polynomial? See, children, I'll teach you one important thing. If I have a linear polynomial, so that means the highest value of the variable will be 1. So you will write x, and there is no other variable because x to the power 1. So you can write ax plus b. This is the general formula for a linear polynomial. For a quadratic, it becomes ax square plus bx plus c. For a cubic, ax cube plus bx square plus cx plus d. So you keep on increasing the letters, right? You keep on increasing the letters. Linear is ax plus b, quadratic is 3 terms, cubic is 4 terms, like that. So now, for a quadratic polynomial, we study the relationship between alpha plus beta was minus b by a, and alpha into beta is c by a. Now we will study the same thing for cubic, right? Okay, children, one more thing is, what about linear? Does linear also has such kind of expression? Yes, linear also has, but that is not very noticeable. Why? We are not really studying into that because that's very simple. See, children, linear polynomial has only one zero. And what is the formula for that zero? The formula for that zero is minus b by a. Simple. That's it. The value for 1, 0 is minus b by a. That's the value of x over here. And x is only the value, the zero. Right? So this is how you get. Next is, see, look here now. The sum of the zeros for a cubic polynomial becomes the coefficient for x squared divided by coefficient of x cube. Okay, so what is the coefficient? If I have to write ax square, ax cube plus bx square plus cx plus d. So can I make a formula for it? Coefficient of x square is how much? Minus b by coefficient of x cube is how much? A. Now, children, you see, actually the formula is the same thing only. You see, try to understand now what is b over here. The b value is not same. B was the coefficient of x in quadratic polynomial, but here b is the coefficient of x square. Earlier, a was the coefficient of x square, but here a is the coefficient of x cube. Children, are you even understanding, or everything is just like blank? Are you all understanding what I'm trying to say?
Yes,
Yeah.
ma'am.
Yeah. See, so basically, the format remains the same. Whatever formula you are writing, you are going to take a minus sign, the coefficient of the second term. Second term is, now second term changes. The second term is bx square over here, divided by coefficient of the first term. That is the sum of the zeros. For product of the zeros, you take the constant term. So that's d minus, but here you will include minus sign also, divided by coefficient of x cube, coefficient of the first term, that's a. Okay, so the formulas are a bit changed, but the concept, children, that remains the same. Okay, what is the concept? The concept earlier was coefficient of the second term divided by coefficient of the first term for sum of the zeros. For product of the zeros, it's always the constant term divided by coefficient of the first term. I tell you, you remember it like this, you'll never forget anything. And you'll not even have to memorize any other formulas. Okay? Some of the, I'll just write it down. But you will have to remember these three things. For a linear, what is the general formula? For a quadratic, what is the general formula? And for a cubic, what is the general formula? After this, you will remember it like this. Sum of zeros is equals to negative of coefficient of second term divided by coefficient of first term. Now this is valid for quadratic as well as cubic. If I have to form the formula for quadratic, it becomes minus b by a, because b is the second term, a is the first term. What does the formula become now for a, alpha plus beta? For cubic, it's the second term. Second term is b, again divided by first term, that's a, right? Product is constant term divided by coefficient of first term. But now, children, there's one catch over here that basically the formula for product for a quadratic polynomial is positive, but for cubic it is negative. Okay, for a cubic one you will use alpha into beta is minus b by a, but for quadratic it's c by a. Tell me, do you understand these all points what I've mentioned here?
Yes, ma'am.
Yes, ma'am.
Yes. So now we shall come to a few questions after the concepts.
Yeah.
Okay, there's one more formula for over here. You can remember this formula also. You also have this formula. Alpha beta plus beta gamma plus gamma alpha. See, children, basically because some of the zeros are actually, there are three zeros for cubic. So it's alpha plus beta plus gamma, right? So alpha plus beta plus gamma is minus b by a. Gamma is nothing but the third zero because there are three zeros for a cubic polynomial. Alpha plus beta plus gamma is minus b by a. Alpha into beta into gamma is minus d by these two formulas I made you learn. The third formula you just remember now what is remaining? Remaining is C. So it's C by A for alpha beta, beta gamma plus gamma. Okay. Now just come to this question. Verify that 3 minus 1 minus 1 by 3 are the zeros of the cubic polynomial. This and then verify the relationship between the zeros and the coefficients. It's a very simple but a very lengthy question at the same time. What you do is, first of all, what are the three zeros? 3 minus 1 and 1 minus 1 by 3. Assign the values. Alpha is 3, beta is minus 1, and gamma is minus 1 by 3. Okay. There's a cubic polynomial, and what is the cubic polynomial? 3x squared, this is it. 3x cube minus 5x squared minus 11x minus 3. Now you have to, one by one, verify that these are zeros or not. So one by one, just put the values. So first you put the value as P3. Just put the value as 3. X is equals to 3. So what is the polynomial? 3x cube. So instead of 3x cube, children, you can write 3 cube minus 5, 3 square minus 11 into 3 minus 3. Okay, and you can one by one put the values and get your answers and check it quickly. So can you do the first part of this question? Tell me, children. Can you do the first part of the question?
Yes, ma'am. Yes, ma'am.
The children try to do this, children, and tell me if you're stuck at any. Children completed.
No, ma'am.
Children, just verify that these are zeros or not, okay? Children, have you still not completed? We can discuss it once if you're stuck anywhere.
Almost done.
Okay, children.
Done, ma'am.
Okay, children. So now, tell me which of the following do you think are zeros or not? I'll just tell you the first solution. Now, Zeb and Saad, please look on the board. Okay, and just recheck your answers now. So I was checking for first P3 value. So 3 cube is 27 minus 5, 3 square is 9 minus 33 minus 3. Right, children? I've just cubed and squared 3 wherever it was necessary. Now you will just multiply 3 with 27, 81 minus 45 minus 36 you're getting 81 minus C. 45 and plus 36 is also 81 only. And 81 minus 81 is 0. So that means is P is 3 a 0 of the polynomial? Yes. So this is verified. Why is it verified? Because the value that comes out to be after substituting it in the polynomial is 0. Okay. Now similarly children, I can check for minus 1 and minus 1 by 3 also. So what are the values that are coming? Tell me, is it coming yes or no for both of them?
Yes, ma'am.
Yes.
And this also, is it yes? Okay. Children, so do you have any doubt? Let me just check. Yeah, it's 0 only. Do you have any doubt? Is it clear? Children, please tell me, do you understand? Is there anyone who has doubt in this part?
No, ma'am.
No. Okay. So next we have is you have to basically verify the relationship between zeros and the coefficients. So again, that's very easy. What was the formula? The formula for alpha plus beta plus gamma was alpha plus beta plus gamma. What was the formula for that? Who will tell me?
Minus B by A.
Minus B by, very good. So what's alpha plus beta plus gamma? 3 minus 1 minus 1 by 3 is equals to minus B by A. So what's minus B over here? Minus 5 is the value for B and 3 is the value for A. So that becomes minus 5 by 3, right? Let's check. The LCM over here is 3, right? Wait, you can do like this. 2 minus 1 by 3 is equals to plus 5 by 3. See children, you will get 5 by 3 here also. 6 minus 1 is 5. Okay. So the first relation is verified. What about the second one? Alpha beta plus beta gamma plus gamma alpha is equals to, what was the value now? Who will tell me? Tell me children.
It will be 3 into minus 1 plus minus 1 into
Then I
minus
was
1 by
asking
3
the
plus minus 1
the formula. I was asking the formula. That's C by A, right? I just want to know if you
yeah.
remember. Yeah. Now, children, you will just do one thing. Just multiply alpha with beta. So 3 into minus 1 plus minus 1 into minus 1 by 3 plus minus 1 by 3 into 3 should be equal to C by A. Now, what is the value of C? Check from the polynomial. The value of C is 11 UC, right? Children, this is A, this is B, this is C, and this is D. So the value of C is minus 11, right? 3. So minus 3, this becomes plus 1 by 3, minus 1, it should be equal to minus 11 by 3. So minus 3 and minus 1 is minus 4, plus 1 by 3 should be equal to minus 7 by 3. So this comes out to be 3. Minus 12 and plus 1 is also minus 11 by 3 only. So minus 11 by 3 is equals to minus 11 by 3. Hence, verified. Right? Yes. So, children, the third one you can now do on your own. Alpha, beta, gamma. Now just come to the exercise questions. I'll just tick mark a few. Quickly complete them. And we'll move ahead. So, from here, you have to find the zeros of the quadratic polynomials and verify the relationships. So, children, how are you supposed to find the zeros? Can somebody tell me? How do you find the zeros?
By factorization method
By factorization, exactly.
of
And children, now
a formula.
factorization. See children, factorization is basically dependent upon what kind of question is it. It can sometimes be middle term splitting, or it can be using an identity, or it can be without an identity, you just have to take HCF and solve. So I'll give you one of each type. Do fifth one, fourth one, and do third one, second one. Okay, quickly do these three. I'll even give you hints. The second one is based on middle term splitting, right? Because it has three terms. The fourth one is basically you just have to take common and solve. The fifth one, you have to use an identity. Who can tell me the identity that we can use in fifth one?
A square minus B square.
Exactly, a square minus b square. So children, quickly complete these three questions and tell me.
Ma'am, done.
Okay, children. So let's discuss the answers. Let's discuss the answers.
Yeah, ma'am.
Yes. So what about Zeb and Saad? Children, have you completed?
Yes, ma'am.
Saad, your camera is again off.
Oh,
Yeah, put on your camera. Okay, so children, look here. You have 4s square minus 4s plus 1. So children, you will do it by middle term splitting, right? So for middle term splitting, what do we do is the process includes that you take the first term and the last term and you multiply them. So 4 into 1 is 4 only. And now what are the factors of 4? Factors of 4 are 1, 2, and 4. Now just make such pairs of these factors so that you get minus 4, right? See children, there's one more better way to it. Basically, 4 can be written as 1 into 4 and 2 into 2. These are the only two ways how I can break down 4. Now just make pairs from these two things. I always follow this method, the second one. Why? Because the first method is also correct. I'll tell you how and why is it a bit tricky. But right now, focus on the second method. 4 can be broken down as 1 into 4 and 2 into 2. Now, 4 plus 1 cannot be equal to 4. I want this center one answer. But minus 2 and minus 2 can give you 4, right? So I'll take 4s square minus 2s plus 1. This is the way I will break it down. So 2s becomes common. You take 2s minus 1 minus 1 and then 2s minus 1. Okay. So 2s minus 1 and then 2s minus 1. So what kind of factors does it have? It has two identical factors. So can somebody tell me what kind of graph will it have? How many points will it touch?
Only 1 point.
Only 1 point, right? A parabola that's touching only 1 point means that it has two identical solutions. So everyone understood this one, middle term splitting?
yes, ma'am.
Yeah. I was telling you why I'm not using the first one. See, if I'm doing it by the factor method, I'm writing the factors and everything. What happens is now it becomes very confusing. Children get confused over here only that I have to take 1, 2, and 4, make combinations. Now they're stuck at 1, 2, and 4. They do not think it in this way that they can take a factor twice also, because 2 and 2 also they can take, right? So that is why I do not go by the factor method. I always prefer this method because this always gives you a very quick and easy answer. Next is 4u square plus 8u. So children, this I can directly take common. 4u comes out to be common. In the bracket you have u plus 2. So my factors are 4u and u plus 2. Over here it goes by t square minus root 15 square. So my factors are t plus root 15 and then t minus root 15. Right?
Yes, ma'am.
So now come to the second one. Now you have to find a quadratic polynomial with the given numbers as the sum of the product and its zeros respectively. Now it's the same question. So
Ma'am, the fourth one, can you do again?
I'll do again. You want me to write it again? Explain you?
No, no. Okay. No, ma'am. Yeah.
Shall I raise it now, children?
Yeah.
So now children, basically see the sum of zeros alpha plus beta is 1 by 4 and alpha into beta is minus 1. right? Now, how can you write down it? Just write it equal to minus b by a. Write it equal to c by a. What is the value of a now? What is the value of a?
A is 4
Okay, a is 4 and b is from the first one
minus 1.
minus 1. Very good. But now, children, this is from the first part that I've told. But now look at the second part. The second part says that c by a is minus 1. So from here, you should have a as 4, a as 1, isn't it? But a is 4. How come?
C will become minus 4.
Very good. Children, if you want to make a equal to 4, so this should be equal to minus 4. Then only it simplifies to minus 1, right? You have to think logically here. There is no specific solution. You have to think logically, use some logic, and then do it. Okay. So basically, c by a is minus 1. And I know a value. See, first you always solve from the sum part because there you will get the value of minus b and a. Okay. Then come to here. So now I have the c value is minus 4. Now it becomes a square. So ax square is 4x square. Bx is how much? Minus x minus 4. Okay, this is your polynomial. Children, so polynomial also you find quickly for do this one, then do fourth one, do sixth one, and do third one. Okay, copy the first one, then do third and sixth on your own. Quickly do it and then tell me.
Ma'am, can you erase the pink color writing?
Yes, just give me a second.
And what all question we have to do?
The third and the sixth one, right?
Okay.
Ma'am.
Okay, let's wait for a minute for Zeb and Saad. Zeb and Saad, when you've done, just tell me. Umair, if you're done, you can practice the remaining questions, okay?
Done.
Okay, good children. So I will just quickly discuss the remaining answers also. Focus on the board. The question says 0, comma root 5. So alpha plus beta is 0, that's equal to minus b by a. And alpha into beta is root 5, that's c by a. So now children, from here I clearly have the idea that the value of c is root 5, the value of a is 1, okay, and the value of b is 0, right? Right, children?
Yes, ma'am.
Omer, are you focusing on the class?
Yes, ma'am.
So now it becomes ax square plus bx plus c. So x square plus 0x plus root 5. So our answer is actually x square plus root 5 only. Okay. The second one is 4 comma 1. So 4 comma 1 is alpha plus beta is 4. Alpha into beta is 1. Okay. So basically alpha plus beta is minus b by a. That's equal to c by a. Right? So the value of a we know is now 1. The value of c is also 1. The value of b is 4. So my polynomial becomes x square plus 4x plus 1. Okay?
Yes, ma'am.
Yes, children, like this you can do. So, yeah, so children, that's it for the lesson. Now you'll do one thing. You will just quickly go through the entire lesson and tell me if you've got any doubts. Just quickly do this thing. I'm giving you all 5 minutes because if you won't have any doubts, I will move ahead to the next lesson. If there is any concept, any formula you did not understand, quickly go through it. 5 minutes you all have.
Okay. Ma'am, what is the shape of the cubic quadratic equation? Cubic equation?
One second, I'll show you the figure once again. Just give me a minute. I was downloading the other PDF. Okay, so children, next I will start with is linear equations. Okay, I'll address first Umair's question. Yes, Umair, tell me your question again. What was the shape of cubic polynomial, right?
The
The graph
cubic
of a cubic
polynomial, yeah.
polynomial. That's basically not any specified shape, but you can call it S-shaped. See, you will see something like S-shaped. See, it's something like S. Okay, so you can write S-shaped,
Okay.
right? Any other?
No, ma'am.
No, ma'am.
Okay. So, Zeb, you want to ask anything?
No, ma'am.
Okay. So, children, we will now start with a new lesson that's linear equations. Okay.
Okay. Ma'am, can we do quadratic equation, coordinate geometry?
Coordinate geometry you want to do? See, I have to
Yeah.
do a few lessons in order. I have this list which I have to follow. That's real numbers, we did. Then polynomials, then linear equations, then quadratic, and then coordinate. Do you have any specified test that's scheduled?
No.
Um, if you
No,
want to
ma'am.
do. See, actually, the point is, Umair, I want to start with this chapter. Why? Because this is a very big chapter. Coordinate geometry is just about one class. So, shall we take that up after this lesson? Because I want to revise the
Okay.
major chunks first. Will that be fine?
Okay. Yeah.
What about Zeb and Saad? Children, are you fine with that, or you also want to do any other lesson?
No, ma'am.
No,
Linear
ma'am.
equation.
Linear equations are fine. The only
Yeah.
reason being that this is a huge chapter, and more questions will be coming from this chapter. So first, I want to revise the major chunks. Okay,
Yes,
so
ma'am.
look here, children. Pair of linear equations in two variables. Basically, now we come to linear equations. What happens is, in this lesson, we'll be studying all the linear polynomials. You remember linear? Linear is having the degree 1, right? So we studied the lesson polynomials. Then we have the lesson linear equations. After this, we'll be doing quadratic equations. So it's in series. We studied polynomials. We had a basic idea. Now we'll be studying in depth about linear equations. Linear equations are basically the ones that are having the general format ax plus b, right? But the point over here is, children, this chapter deals with linear equation in two variables. Now, this is an important point, and this is what makes the basis of the lesson. We are not just doing any random chapter. We are doing two variables equations we'll be dealing with. Basically, now you don't just have x with you, but you have two variables. That means I will have ax plus by with me and a constant term c. So this will be my linear equation in two variable. It has two variables. One is x, other is y. It's not necessary that if they are x or y, they can be anything. But for reference, you consider that it as x and y. Okay.
Yes, ma'am.
Now, what happens is, children, to find the solution when I have only one equation, I see whenever there is only one variable, I need one equation for that to find the solution. If I have two variables, see, one variable means I need only one equation to solve it. If I have two variables, so children, I will need two equations also. So in every question, you will come across this thing that actually you're going to deal with two equations. So the other equation will also have the general formula of ax plus by plus c, right? But the only difference is the terms will be different. So you have two equations if you want to find the zeros, but here you'll refer it as a1, this is a2, this is b1, this is b2, this is c1, and this is c2. Okay. See, when you come across the chapter, you'll understand it better. Let's come to these things. Okay, the first very important part is let's suppose you have these two equations with you. X minus 2y is equals to 0 and 3x plus 4y minus 20 is equals to 0. So these are your two equations. So what you will do is, first of all, you compare the values of a1. So first of all, tell me, children, if I write it down here, x minus 2y is equals to 0 and 3x plus 4y minus 20 is 0. Children, if I compare, can you tell me what is the value of a1? What is the value of a1? Put on your mic and speak.
A1 is 3.
Yes. A is
A1 is 1, ma'am.
A1 is 1. Yes. What is A2?
2 is
A2 is 3. What is B1?
B1 is 2. Minus 2.
Minus 2. And what is B2?
Plus 4.
4.
4. Very good. What is C1?
0.
There is no C value. What is C2?
Minus 2.
Minus 2. Very good. So now, children, basically these are the comparisons that you get. A1 by A2, B1 by B2, and C1 by C2. Children, please just give me a minute and copy this down. Okay, just give me 1 minute.
Ma'am,
Yes, children. So I was telling you that A1 by A2, B1 by B2, C1 by C2, you're comparing. Now what happens is, similarly, you can have various different types of equations and you can compare A1, A2, all the values you can compare one by one. Now, there exists certain relationships between the values. If the relationship is that A1 upon A2 is not equal to B1 upon B2, or A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2, or first two are equal, then the third one is not equal. You can have either of these relations, right? You can have either of these relations, children. Now, according to these relations, it depends how many solutions you're going to have. For the first relation, you will have only one solution. For the second one, you will have infinite number of solutions. For the third one, you will have no solution. Okay? Now, children, the graphical representation is basically, for the first equation, the graph is intersecting lines. Like the first line goes like this, the second line goes like this. For the second one, the lines are coincident lines. If the the line of the first graph is like this, the graph of the second line is also on this one. Okay. Now, last is parallel line. When you have a relationship like this, you will have parallel. So, children, this is a very, very important part of this lesson. Okay.
ma'am,
Yes.
isn't the class supposed to finish at 9?
Today you have an extra class. You have 1.5 hour class today. You didn't get the notification.
No.
Class is supposed to be 1.5 hour today. See, children, now we'll be having 1.5 hour class until your exams, okay? At least this week or by the next week, because I want to quickly complete your syllabus. I'm so sad,
Okay.
right? I'm so unhappy. Where were you waiting for 9 p.m.?
No, ma'am, I thought it was finishing, ending at 9.
Nobody asked me, only your mayor did. Children, you have your exams, right? So we will quickly complete the revision. And then if we'll have remaining time, we'll cover extra questions also. So that is why just study extra for a few days, right?
Okay.
When are your exams, children, anyways? Like on which dates do you have your exams?
September 18th is the first exam.
So like your maths exam is on which date?
Maths exam 2nd October.
Okay, so Zev has a lot of time. And where yours? Saad, yours?
I don't know.
Okay, put on your mic and speak, Saad.
Ma'am, I don't
I'm not.
You don't know?
take it.
No. It's probably on October or something.
Only. Okay, so children, keep try to cover as much part as we can the revision portion in September. Okay. But you also have to keep in mind that revise the concepts on your own as well. See, we are just having 3 classes in a week, and that's not enough. So you have to cover portions from your own self only. I am doing the important things in the class. You have to go after the class, you have to revise all the important things as well as practice questions. So sit and practice, write it down, write down all the solutions on you. Okay, without looking at the solutions from the textbook, try to do it on your own. If you're not, I don't see anybody asking me any doubt. In the class, I'm always asking anybody has any doubts, anything you want to ask. I feel you're not practicing at home. If you're practicing at home from your textbook, you would be at least some of the question you'll be having read that you didn't understand. Okay, so children, just do one thing, copy this table quickly. Just copy the highlighted part, like the pink annotated portion. Okay.
Ma'am, which one? Graphical representation or algebraic one? Algebraic interpretation. Interpretation. Yeah. Done.
Yes, copy.
Yes, ma'am.
Yes, ma'am.
Okay. So based on these only, I'll quickly give you graphs portion. I'm not doing now. I'll take up it in the next class. Just come to this one. Okay. See now, what does this question say is that on comparing the ratios of A1 by A2, B1 by B2, and C1 by C2, find out whether the lines representing the following pairs intersect at a point or parallel or coincident. So A1 upon A2 is how much? 5 by 7. B1 upon B2 is minus 4 by 6. And C1 upon C2 is 8 by minus 9. So this states that A1 upon A2 is not equal to B1 upon B2. Right? The first part is also not equal. So this is the first case. So match with the case, write your answer. Similarly, do the for the second one and for the third one also. So you just tell me when you're done, okay?
Okay, ma'am. Ma'am, done.
Done? What about Zaid and Saad? Students, at least respond if you're done or not. If not, then say no.
I'm doing.
Tell me for the second one. Okay, first will tell me for the case one, that what kind? Is it party coincident or intersecting?
They are coincident, ma'am.
Coincident. For the first one,
The first one is intersecting.
intersect. The second one, coincident. Let's check. 9 by 18 is 1 by 2, 3 by 6 is also 1 by 2, 12 by 24 is also 1 by 2. Correct, coincident. The third one is 3, 3,